All right, so this is gonna be a quick video going over pages 11 and 12 in your vectors packet. So what we're gonna do is we're gonna start breaking vectors down into components. Okay, so first thing we're gonna talk about is it's called when we find the resultant by adding vectors. So basically what that means is if I have something going, I'm gonna go to the right, let me switch to my pen. I'm gonna go to the right, and then I'm gonna kind of start diagonalizing up, and then go to the right again, and then I go up, and then I start diagonalizing to the left. So if I were to add up to those vectors, it's basically going to create my displacement, which would be that. Now, we're not going to do a ton of that stuff. We're mostly going to care about breaking down a hypotenuse into your horizontal and vertical components, which is what we're going to do right here. So that basically means is if I have a hypotenuse, looks like this, okay, I can break it down into my x component, and I can break it down into my y component. And you can do that on the opposite side as well. So I can break it down in my y component here, or I can break it down into my x component there. So let's do an example of what it actually looks like. So if an airplane flies at 360 kilometers, so there's your magnitude, at 30 degrees north of west, so there's your direction. So this is a hint. Anytime we give you a magnitude and a direction immediately with it, that is the hypotenuse. Okay, so what I'm gonna do is I'm gonna draw my cardinal directions. Okay, we're talking about north and west, so I only care about this top left quadrant. Let me change colors. So I'm going to go 360 kilometers. So I'm just going to draw an arrow. Okay, now I have to figure out where's my angle going to go. So 30 degrees north of west. So west is the last letter, so it's going to touch the west line and go up from there. So there's my angle, so that'd be 30 degrees. And that means my hypotenuse would be 360 kilometers. So it says find the distance where it traveled north and west. So I'm going to find my north. Okay, which is your y component, and I'm going to find my x, which is your west component. So I have a hypotenuse, and I have an angle. Okay, so again, that little circle with a line through it just means theta. That's just a symbol for angle. So let's do this one at a time. So there's not one function where I can find them both, so I'm going to have to do two functions. So remember you have your SOHCAHTOA, so sine of your angle equals opposite over hypotenuse. Okay, cosine of your angle equals adjacent over hypotenuse. And then tangent of your angle equals opposite over adjacent. Okay, so if I'm looking for y, y would be your opposite. Okay, because it is opposite of your angle. Okay, so if I'm looking for my y, I need to figure out what has, let me switch my colors back. So I'm going to look for opposite. So I would look at my three trig function and says which one has hypotenuse and opposite. Well, that's going to be your sine. Okay, so we're going to use that to find our y. So sine of our angle, which would be 30, equals opposite, I don't know, so I'm going to leave that as y, over your hypotenuse, which is 360. Now, all you got to do is one, make sure you're in degree mode. Two, you're just going to multiply both sides by 360. Okay, and you're going to get a y value of 180 kilometers north. So there is half your answer right there. Don't forget to put the direction there because you got to tell me which way it's going. Okay, so now what we're going to do is we're going to find our x component, and that is our adjacent side. So remember, adjacent means next to the angle. So I would see which function has hypotenuse and my adjacent. Okay, so that is going to be your cosine. Now, could you do a squared plus b squared equals c squared to find the one part of your triangle? Yes, you could. Okay, so again, I just like to stick with what they gave me instead of what I found, just in case the answer that I found was wrong. I don't want to take that wrong answer with me. So I'm just going to stick with, with what they gave me. So I have my hypotenuse. Okay, I'm looking for my adjacent, so I'm going to use my cosine. So cosine of 30 equals x, that's my horizontal, over my hypotenuse, which is 360. So if you notice, it looks exactly like we did for y. We're just using cosine now. Okay, so multiply both sides by that, by 360. And you're going to get 311.77 kilometers west. And there's the other half of your answer. So we just use sine and cosine to break it down. Okay, so the next page we're going to do is we're just going to work with a little more SOHCAHTOA stuff. And then in the next video, we're going to do a lot more breaking down hypotenuses into the vertical and horizontal. So a curling rock slides across the ice at an angle of 5 degrees from the horizontal. So what that means is if I draw my directions, you can go left or right. It just means that is 5 degrees above the horizontal. So again, you could go the other way if you want to. Doesn't matter to me, it's just totally your preference. Okay. If the button is 36.5 meters from the release, okay, so it says it stopped to the side of the button. So it stops right here. The button, the target you're looking for in curling was right there. So my distance right here is 36.5 meters. So it's asking how far to the side of the button does a rock land. So we're looking for this. So how far did it land to the side? Okay, so we have an angle. We've got a side of a triangle. We just need to figure out what do we have. So we've got an angle. Okay, now that 36.5, it's right next to my angle. So that is going to be your adjacent. So we've got that. And we're looking for, this would be the opposite side. So we are looking for opposite. So we would see which of those three trig functions has, opposite and adjacent. Well, that's going to be your tangent. Okay. So tangent of your angle will be 5, equals opposite, we don't know. So I'm going to leave that as a question mark. And adjacent would be 36.5. And we'll just put that there. Now we're just going to do is we're going to multiply both sides by 36.5. And you're going to get a value of 3.19 meters. So that's how far to the side of the button it landed. Okay, so that was really just practice. You got to know what you're given in a triangle and then what you're looking for. So B, how far has the rock traveled? So if I want to know how far did it travel, I'm looking for the hypotenuse basically. Okay, so I want to figure out what is that displacement. So there's two ways you could do it. You could do a squared plus b squared equals c squared, since now you know that this is 3.19. Okay, so again, you just have to make sure that 3.19 is correct. Okay, what I'm going to do is I'm going to stick with what I was given. I was given an angle. Okay, I was given adjacent. And I'm looking for my hypotenuse. So I'd see which of those three trig functions has adjacent and hypotenuse. That would be your cosine. Okay, so cosine of 5 equals adjacent, which is 36.5, over hypotenuse. We don't know. I'm going to leave it like that. Now, just be careful. Don't multiply both sides by 36.5. You could do it up here because it was on bottom. Okay, but you cannot do it here. Okay, what you can do is you can switch these two. Okay, so it would actually be 36.5 divided by cosine of 5. Okay, so that basically means my hypotenuse is going to come out to be 36.64 meters. And that is it for this video.